going through something that's basic electronics because someone asked me about something now, so I have to go back to basic electronics. This is the lamps. These are bulbs. This could be your parking lamps. This could be your headlamps. This could be your braking lamps. Switches can be used in many functions in many situations. This is called a single pole double throw. The position of the switch, and in order to understand automotive, you have to understand this. That's why I'm even going to this. Switch is S2. Current flows from the power supply. Now notice the power supply, 6.3 volts, what? AC, not DC. This is called AC RMS. Whenever you see AC, it means RMS value. That's a different video that I did. But I want to show you that it means it's alternating current. What does alternating current mean? Alternating current means the current flows in one direction, as you see, switches polarity, and it goes back in the other direction. So see the arrow going this way, then it goes this way. What's the difference between direct current? Direct current means it's always going in the same direction. Now, besides that point, switches. We have to know switches in order to understand automotive. The switches can be at two positions. When the current gets to this point, it thinks, which path can I take? How many paths are there for the current to take? One path through here, another path through the green path that I put. Let's go to both paths. If the switch is in the upper position, we follow the pink line. We come into DS1, the lamp, the brake light. We come out, right? We come out. Problem. Current thinks to itself, it sees another connection right here. See that connection? Can we go through that connection? Well, let's try. Current will come out here, out of DS1, come over here at a standstill. Let's say, okay, there are two paths, this path and this path. If you go through DS2, you go up here, you go up here. Which way is the switch in? It's in the upper position. That means there's no connection. So therefore, the current cannot go through DS2. So what's the only logical answer? Current goes in here and goes right back on the pink path. If the switch is turned in the lower position, which one is turned on? We said in the upper one, DS1 is active. What about the lower one? If you go in the lower one, switch is in this position, goes here, comes into DS2, comes out DS2, cannot go back up through DS1 because now the switch is in the green position. Goes over here, goes over here. So therefore, in this position, DS2 is active. In the upper position, DS1 is active. Let's take a simple case. This is double pole single throw. You can have the position of this one. Current goes here. This is closed, and this is normally open. When we close it, this makes a connection from here to here. This makes a connection from here to here. So 2 points are closed. Over here, 1 point is closed in the circuit. Here, 2 points of the circuit is closed. Why would we need such a switch? Just to do one lamp? Maybe you're in a hallway. Maybe you want to turn on the lamp in your house or the light in your house from two different positions in your room or in your hallway. If it's a long hall, maybe in the front I'll have one switch and in the back of the hall I'll have another one. Both activating the lights. So current flows here, 3 here, 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 and then reverses back. Simple. Okay? Let's go over here. Double pole, double throw. A little more intense. Here, here, here. The switch is in an up position. Follow the green. Goes in here to DS1, comes out DS1. And where does it go now? Well, look at the switch. It's in the upper position. It can only go in here. Back to this. Let's go in the lower position. What is this dotted line? That means they're ganged together. When I flip the top, I also flipping the bottom. So if we flip it the other way, S4 is now in the pink, the top, and the bottom is also in the pink. Now current flows here through the pink. DS2 comes out DS2. Where does it go? In the pink. Here. Why? Because now the switch is down. The switch is down in the pink position. What happens when it's up? When it's up, it goes through DS1, comes out here. When we activate it, it goes here, and it goes on the bottom. Here. DS2 is activated. That's why I said this is DS2, this is DS1. Let's take a difficult one. Again, we're ganged together. When I flip this part of it, I flip this part of it. Come over here, we come over here. Go in here. We come into this switch. We go out the switch. Right? We're in the upper position. Upper position means 2 is connected to 3. We went in, current flowed, comes out. Where does it go now? 6 is connected to 3 because it's in a rest position. We go here, and back to the supply. We flip the switches. So now 2 is not connected to 3. 2 is connected to 1. 5 is not connected to 6. 5 is connected to 4. But look at this. There's no connection here. Different, right? So what happens? Current goes in here. 2 is connected to 1. Current flows here. Goes here. Right? Goes over here. Goes over here. Goes over here. Goes over here. And back through this. Okay? So here. Through 2, 1. Through this. Back in, out of DS1. Into DS2. Out of DS2. And this is now open. It can't go there. It goes back to the supply. So both of them are on. Anyway, please go to my channel, Joe Electronic Schematics for Auto. Please go to my other one, Automotive Electronic Schematics by Joseph. Thanks for watching.